Alright guys, so our next goal today is to now keep solving by factoring. So a couple of tools here. First, when I see any kind of quadratic equation problem or equation, I think about a few things first. I always first want to make sure that my equation is in standard form. What that means is that it's equal to 0. So in this case, because it's equal to 0 here, this is in standard form, so I'm good with that. I can move forward with the question. Next, I always want to check for a GCF. What that means is I want to check if there's any common factors between the terms, because if I can do that in the very beginning, it makes my question smaller, which makes it easier to work with going forward. In this example, if I look at 2, 14, and 24, they all share a 2 in common. So I can divide the 2 out. That's kind of hard to see, guys. Let me use blue here. So I can divide by 2. And if I do that in the very beginning, 2 divided by 2 here is I'm left with x squared. 14 divided by 2 is 7x. And then 24 divided by 2 is 12. So I'd much rather work with this quadratic here in the parentheses than the original one given to me. Again, this GCF that I divided out in the very beginning, it'll kind of sit on the side. It'll come back at the end for my final factored form answer. Now I want to solve by factoring. So when I look at this quadratic, I recognize that in this example, a equals to 1. And so that's going to open up for me a quick way to factor this quadratic. I'll make the x factor. Again, here for this top value, it's a times c, so 1 times 12 is going to be 12. And then my b number here is 7, which goes down here in the bottom portion. Now, in this case, I know that 12 is 3 times 4, and that can add to make 7, so I'm going to choose 3 and 4 in this case, and so this x factor works. But guys, we've learned that when a equals to 1, we can make the x factor, and then from this part of the problem, I can factor, actually I can, at this point, go right into factored form. So I can bypass the grouping here because a equals to 1. So I can fill in these x's. I'm not going to forget that I have a GCF of 2, so I'm going to go ahead and put that now in front, because it has to be there in the end. And in this case, to finish my factors, I simply will input these two numbers that I found, this 3 and 4. I'm going to input them into the factor. So 1 is plus 3, and 1 is plus 4. So I've now factored this quadratic. Once it's in factored form, I can now solve it by setting each factor equal to 0. So here I can say either x plus 3 will equal to 0, or x plus 4 will equal to 0. And if I solve these little equations, I can find pretty quickly that x is going to equal to negative 3. Sorry, that's a 3 there. Or, in this example, x can equal to negative 4. So in this case, I've now solved this quadratic by factoring, and my solutions are negative 3 and negative 4. Guys, recall that I can call these solutions roots, x-intercepts, or zeros. Now graphically, negative 3 and negative 4, I could plot these points in the graph, and it's kind of hard to see, but negative 3 and negative 4 are here. So I know that if I were to graph this quadratic, I would see my parabola crossing at these 2 points. If you go on Desmos and you type in the original quadratic, don't include the equal 0, you will see that the graph does cross at negative 3 and negative 4. What's your solutions to this question?